I don't think the numbers are going to do any justice here. So what do you got? What are my methods here again? Angle, angle, side.
Angle, side.
Yep.
Side. Angle, side, angle.
And that's it. That's it. Notice 1, 2, 3, and 4 don't say choose your own method, right? Is angle, angle, angle up there yet? Nope. Side, side angle. Nope. It's never going to be up there. And unfortunately, the train can't stop for some of you. So we have to go on to our fifth and final method today. All right, fifth and final method, which is called HL. And I do this last because it's a little unique. We know what the S's and the A's stand for. That's sides and angles. So what's the H and the L stand for? Here you go. The H stands for hypotenuse. Some of you may or may not have heard of that term before. I'll go over it. The H stands for hypotenuse, and the L stands for leg. Hypotenuse and leg. This method, I don't know if you want to circle it, star it, point to it, highlight it, whatever. This method can only be used if the two triangles are right triangles. Okay? If they're not right triangles, HL will never be an option. Okay? So this method, only if you're given right triangles. Okay, so let me talk here real quick, because I know some of these vocabulary terms are unfamiliar to you. Have you ever heard of the word hypotenuse? Okay, do you know where it's located on a right triangle and how to find it? What do you guys know about hypotenuse? Scott, what do you know?
It's the side that's opposite of the angle.
Okay, it's this. Thank you. That's how you can always find a hypotenuse. It's across opposite the right angle. So here's what you need. You need both of them to be congruent to each other. That's the H and HL right there. Everyone see it? That's the H and the HL. And then the L means a leg. That's what the other two sides are. So you at least need another pair of sides equal. There's HL. There's HL. Hypotenuse, leg. Or, here you go. Leg. Okay, that's HL as well. All right, that is HL. Is that HL? Do you think that's HL? No, I don't have the hypotenuse. But it's still congruent. Why? By what method? That's still side angle side. I'm showing you this because I don't want you to get in your mind right triangle, right triangle, right triangle equals HL. It doesn't. What method did you just tell me this was? Side angle side. So don't get this in your mind that just because I or you see a right triangle, that automatically means it's got to be HL. It doesn't. It could be another method. You got to have the hypotenuse and the leg. Any issues, questions with this? But it's got to be what triangle before we even start? It's got to be a right triangle to even sniff HL. If it's not even going to be a method. All right, let's keep going then. Let's try a proof out. Looks like I only have, how many proofs do you have? 2 or 3? 2, I hope. Just 2 today? Good. Perfect. All right, I'll go through this one with you, then you're going to do the second one in your groups. All right, so let's label all this together. ABC is a right angle. DCB is a right angle. AC is congruent to DB. And I need to prove the triangle's congruent, so you have 5 methods now to do so. Nothing you make up on your own. 5 methods I've given you. All right, let's make a plan before we write down step 2. Anything else you can mark on the diagram by yourself? Zach?
Reflexive.
Which one?
CB.
Okay, everyone agrees CB is reflexive. Okay, I'll write that down eventually. I want to make a plan though. All right, do we have right triangles? Okay, so we do. Maybe it might be HL. I'm not assuming it is, but maybe it's HL. What are BD and AC in these right triangles? What are we calling AC and CD and BD in these right triangles? Those are my hypotenuse, right? My hypotenuses, whatever you call them, plural. All right, everyone agree. Those are the hypotenuse. And what's the reflexive side Zach just gave me? That would be a leg. Do you see HL?
Yes.
Why is it not side angle side?
Because hypotenuse, like,
No. Why is it? Why can't I use side angle side? I have side angle and a side. What's the problem? If we know this stuff, is the right angle in between? No. So that's why it's not side angle side, but I can use HL here. Correct. All right. What's still got to go in the proof? I marked it on the diagram, but I didn't write it down yet.
where's the reflexive?
Yep. CB equals CB. Reflexive. That's got to go in there. Now, I wish it was easy as just saying, question, Lisa? I wish it was just as easy as saying I could write the triangles are congruent by HL, but I can't. You guys have a note up on right at the bottom of HL? What's that note say?
We must establish that you have right angle to use HL.
If you have right angles?
Right triangle.
Right triangles. Have we established that?
No.
No. What I mean by established is it's got to go in your proof that you have right triangles, because HL can only be used for right triangles. So you better tell me before you write down HL, yeah, I have right triangles here. So let's name them. Triangle ACB and triangle DBC. Doesn't matter. The order doesn't matter until I write the congruent statement. These two are right triangles. If you want to use HL, you better tell me where your right triangles are. Anybody have any idea how we know they're right triangles? Not looking for anything complex. How do I know those two are right triangles? Because they have
Right angle.
right triangles have
Right triangles have right angles.
right triangles have right angles. Whoa, wait a second. Did we make a mistake? Right triangles have right angles. I know I can see in my diagram they have right angles. Did we say we have right angles in the proof?
Yeah, we did.
We did?
Yeah.
Where?
The given.
Okay, good. Just making a point that if you're going to write right triangles have right angles, somewhere in your proof you better have right angles. Not on your diagram, in your proof. And it was given, so I don't have to worry about it. All right, so yeah, go ahead, Luke.
Do you have to set right angles?
Okay, great question. That always comes up. Luke just asked, do I need to set the right angles congruent to each other? Here's our answer. The H stands for what? The L stands for what? Do any of them stand for angles? So in an HL proof, you do not need to say the angles are congruent. If you do, it's still fine. It's a correct statement. Never going to mark off for it. Okay, but in an HL proof, you do not need to say the right angles are congruent. Again, if you do, it's fine. Okay, can't lose. All right, so I told you I have right angles. I got the hypotenuse. I got the leg. We're good. Triangle ABC is now congruent to triangle DCB by my new method, HL. Got to have a right triangles. Got to have your H. Got to have your L. Anything on this new method? Okay, I'll get you started on the next, and I'm going to leave it to you and your group. Before we start marking everything, because you guys can have an opportunity to mark it, look at your proof statement, please. Am I asking to prove the triangle's congruent? Okay, no, but angle 1 and angle 2 are only going to be equal if what happens first? This is going to the other day. The angles won't be equal unless triangles will be equal. So which two triangles need to be equal first? ABE and DFC. So anybody know what's going to happen at the very, 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 very end of this proof when I say 1's congruent to 2? This is going to be what for a reason? Oh boy. CPCTC, correct. So what I'd like you to do in your group, let's go, try to prove the triangle's congruent. So you can say 1 and 2 are congruent by CP/CTC. I'll walk around just listening and seeing what you're writing. Who knows? Maybe it might be an HL proof, might not be. See what you got, see where you can go. You might get stuck here, which is fine. I just didn't want to hold your hand on this. We need practice individually and talking to each other. Get those 2 triangles that have 1 and 2 in them congruent.
So we gotta subtract the EF
Yeah.
from the big thing.
So that's the second side.
So EF equals DE and then EF equals EF and
Yeah.
subtract. Go ahead.
Wait, let me just do a reflexive thing.
Subtract.
Yeah. Yeah.
Yeah.
Let's just say that all of these angles are right angles.
Yeah, that'll be the.
Yeah.
Triangles congruent.
Congruent with the HL because you have the hypotenuse. It's congruent in a given statement, and then you from the subtraction you have this number.
Yeah.
Wait, why?
Triangle ABD and triangle CFD. You can say it.
Oh, you have to take the right.
Yeah. You can try it.
I numbered it wrong.
Yeah, yeah.
I know, I'm seeing it is right.
If that's
right
not
here.
it, I need to write down the wrong angles.
Okay, I'm going to get moving here so you have time to work on your assignment independently too. I just started off my proof by saying I have right angles. Perpendicular lines form right angles. I sure as hope we know that they're there at this point, right? Because if I have perpendicular lines. I also was given AB and CD congruent in the givens. Those are my hypotenuse, right? I have a hypotenuse on both sides. All right, so you guys were in charge of something else. There is a reason why I gave you BF and DE. All right, BF, is that a side in triangle ABE, the one I'm trying to get congruent? Is that a full side? No. It's part of it, but not a full side. So what did I need to do to BF and ED to make them smaller? Go ahead, fellas, I needed to subtract, right? I need to subtract. But I can't subtract right now because I only know those two are equal. I need something to subtract from them. Thank you. Have a good day. I needed something to subtract from them. That also is equal. Via, what do I need to subtract from both of them? EF, yes. So before you subtract, look at your paper. Before you subtract, you need to tell me the other quantity I'm subtracting. EF and EF are equal. Reflexive. That's not a side. I'm using it in subtraction. So now I got BF minus EF equals DE minus EF. Subtraction. And what always came after subtraction in Unit 2, Unit 3, and still in Unit 4? Substitution. To say the sides, or the legs in this case, BE and FD are equal. Still not ready to say HL? What am I still missing here? HL is only for what type of triangles? So you better tell me you got right triangles. So triangle AEB and triangle CFD are right triangles. Right triangles have right angles from the last proof. Now you could say the triangles are finally congruent. Yeah, this is where we are. 8 steps sometimes. 8 steps. HL. And then like we said at the beginning, we wanted the triangles to congruent so we could get 1 and 2 congruent by our CP/CTC. This is where we're going. 8 steps. Some of you may have had 9 if you said the right angles were congruent, which is perfectly fine. Questions? Okay, you have the remaining time to work on the 2 problems. That's it tonight. 2 proofs. And I did post them in the classroom if you want to take a look at my versions. But this is where we are. I'm telling everyone, this is where we are. We're not slowing down. Scott, what's up?
So can you? So I have.
No, because right now, I'm going to say you don't have the legs at this point in the proof. You got the H, because I gave it to you, but you don't have the leg yet. That's why it's got to go down. Okay?